If you Google today's guest, the first result I'm getting at least is to a Wikipedia disambiguation page. I am not interviewing Frank Bell the aviator, the baseball player, the governor, or the radio pioneer. Instead, this is my former colleague, maybe future colleague and friend, and recent author, Frank Bell. The book is Snowflake Essentials, Getting Started with Big Data in the Cloud. When I met Frank, I had a regular sort of 9-to-5 job, and he was a consultant that came in. There wasn't really a cloud then, or maybe technically there was, but certainly not the way it is today. At that company, as in every other company I'd worked with prior, we managed our own hardware for our own database, in that case SQL Server. That was critical infrastructure. If it went down, the site went down. It needed to support transaction-level details in the application. If our traffic went up or we were high volume, we needed that one database machine to rise to the challenge. There were a couple migrations to make it bigger, but the ability to take down the whole production website left us in a difficult position in terms of getting analytical data. The last thing you want is your analytical query to put some sort of transaction or table lock on, and suddenly customers find it difficult to give you money. And the way we solved things at the time doesn't matter, because that was a pre-cloud day. Had solutions like Snowflake existed at the time, we surely would have used those. Frank is the very first person who mentioned Snowflake to me at some date I can't recall. And the main takeaway for me at the time was that it was a database that ran on your data. So put your data in the cloud, do that in a way that's pretty convenient for any data engineers to be able to manage. And then Snowflake runs on top of that, gives users a SQL-like experience without worrying about all the big data underneath. No need for map and reduce, no need for custom code. Just give people a way to do data warehouse-style queries with the compute they bring to the table in a way that can't interfere with your production environment. That structure or that story was super interesting to me as an engineer, and certainly has been to a lot of companies. Frank's book, Snowflake Essentials, Getting Started with Big Data in the Cloud, is a great introduction to these topics. I asked him a little bit about his perspective on the tool and some of the other features it has, as well as what listeners can find in the book. Frank, welcome to Data Skeptic.
Thanks, Kyle. I'm really excited to be here.
So we're going to get into the book and talk a lot about Snowflake, but I thought a good way to kick this off would just be to ask you to give your history and a little background in how you got interested in data.
Well, I don't want to go too much into it, but I guess I've been working with data since early 90s. I originally was interested in it. I mean, I had a ROTC scholarship to the Air Force, and I went in there and I worked with, I think it was Oracle 4 or so back then. And I was just always kind of amazed at how data really controlled everything. Actually, my first exposure to it was through Oracle. And I guess at the time there was some Microsoft Access work I did too. But it was part of what I did at Hanscom Air Force Base was I helped manage the programs that handled air battle planning. And part of that was run out of Oracle database. And so that was, I guess, my initial exposure to it before I got into the internet and moved to California.
And what about the internet changed data?
For me, obviously, I was pretty early into the internet because I was part of the Air Force. I actually managed a program, even though I was in Boston or in Bedford, in Massachusetts, at a Hanscom Air Force Base. I actually managed a software development that was run out of near Hickam Air Force Base in Hawaii. And I still remember the early days. It was just amazing that like a guy from Hawaii could ping me in like 1994 and I'd hear music or something because he'd have access to my computer and send me stuff like live. And then, we actually built a lot of the, like I said, combat command and control data systems. And so that was more on, in the old days on Sun Microsystems, Spark computers. But I was amazed when, like the first time, I think it was like with CGI or through ASP pages where we actually, got a connection string, connected to data, and it really transformed the internet for me personally. And I still think it's to this day that it's gone from this static experience of when we built HTML pages in the early 90s to completely dynamic interactions, whether it's Facebook or Google or anything. Those are all powered by data and these data interactions. And so really got into it in the late 90s, I guess, more and more, and just focused on data when we started my consulting company in 1999.
And I'm not going to take for granted that every listener knows about Snowflake, so would you mind giving us a brief overview for data-minded people and maybe engineers who haven't yet encountered it? What the heck is Snowflake?
Snowflake was started in 2012, and I think we're going to cover a lot about the Snowflake Essentials book. So it was actually founded originally by two ex-Oracle guys, Benoit and Thierry, and then Marcin, like a performance expert, came to be another one of the founding members. And what was different about it, I don't know if it's true, but the story is that they actually tried to build an Oracle, but they didn't approve it. And so these guys met up with an investor called Mike Speiser, and they basically went about building what I think is one of the best RDBMS for OLAP type analytical workloads. And so what they did was they built it from the cloud first, which this is the big thing that I think still to this day differentiates it from all the competition out there. Everything else, like Databricks is really Spark, Google's from Dremel, and then Redshift is really from Postgres. What they did differently is the architecture is based on all their knowledge of 10 or 15 years of doing patents and things at Oracle to focusing it onto the cloud. And so I call it a cloud RDBMS, but they've really positioned it now to be a cloud database. So they call it the data cloud because of its data sharing capabilities where there's zero copying, but it's using the same exact copy, and you can have hundreds or thousands of people sharing it. But at the core, it's really like an RDBMS on the cloud.
So the meaning of relational database has evolved a little bit. I know it's not the same thing as NoSQL, it's still relational, but can you frame this for me in the classic context I'm used to where I have to have a monolith server? Is there anything distributed about this, or is this really close to that traditional database experience?
So Snowflake now runs on the three main clouds. It was originally built, I think, started in 2012 and 2014. Probably, I think it was until 2018 before it ever was ported over to Azure. And then eventually, I think it was 2019 where it went over to the Google Cloud. So it really was built from AWS from the ground up. And the main concept of why I think it's so differentiated from all the other platforms, because I really moved my consulting practice over to focus on Snowflake beginning of 2018, is the separation of storage and compute. While some of the other platforms move to do something similar, they really, if you break it down on AWS terms, but it's very similar in Azure and on the Google Cloud platform, is there's really compute, and that's all done through EC2 machines, all in the background, and you have these t-shirt sizes that you can use on how many of these EC2 instances that you're powering the compute with, and that's completely separated from the storage, which is done on S3. And I think part of Snowflake's secret sauce really is they built some really well-done compression algorithms that made it so a lot of times when we move data over from a Netezza Teradata Oracle, we'll see like 5x compression. So if you had 100 terabytes on one of those platforms, on Snowflake, it'll end up being 20 terabytes. Or it could have even higher compression. And so that's one of the architectural things that makes Snowflake better and work better in the cloud.
When I work on MySQL, Postgres, SQL Server, one of these more traditional databases, I've never built one of those or really been an engineer on a project like that, but I have some sense that under the hood, there's some smart things going on with caching stuff in memory, and that keeps latency down and gives them a lot of advantages for different performance metrics you might want to look at. Reading data from S3 sounds like you could have an overhead and a time to deserialize and all that. Do I pay a penalty by having the data in that format?
Yeah, that's what I would think at first. But I think Snowflake intelligently, like I said, compresses that data so the I/O overhead associated with it is not as high as you would think. And then so they actually, I'll get into a little bit, Snowflake technically has 3 levels of caching. One of the coolest things they did is once you run a query and the results there, they do put that onto the EC2 instance there. So the results cache, if you have the same exact query, like 1,000 times. The second time and higher, that you don't even get charged for the compute. They just store it for you. And that's one of the cooler things. But also what's happening in the back is they are moving that data from S3 into the EC2 instances and distributing it there. So if the warehouse stays on, it gets a kind of what we call warm cache, some of those benefits associated with that.
And when I get into my Snowflake database, I know it's a SQL system, but is it really SQL? Can I do it in the way that I have a lot of extended commands and things like that in a traditional experience? Or am I limited in some capacity?
I wouldn't say you're limited at all, but all the, whether it's Redshift or some of the other cloud data warehouses, you still have concepts of you have to move it to the cloud. So Snowflake has this concept of stages, but it's very similar to other systems as well. You have to, move it to the cloud so it can be processed. But otherwise, Snowflake, I think, like I said, one of the key things is the founders came from Oracle, and they had built, I think, a lot of those functions or the underlying caching that was done there. So it's pretty similar. I think it was made for ANSI SQL, so it has all the basics for sure. But it has a ton of the commands that your listeners would be interested in too. There's regressions and there's a lot of the windowing functions, lead, lag. So I wouldn't say like Oracle's almost too big to me now, but I would say it has like 90% of what you'd expect out of any of these RDBMSs. And, there's even some more advanced, functions that they've added recently.
So I've always heard Snowflake described as a data warehouse, which I think of as something distinct from my kind of transactional day-to-day database that might be run by some software engineers, and then there's like an analytics team that would manage the data warehouse. Is there an opportunity to use Snowflake as a primary database as well?
Well, as of now, Snowflake was really designed for these OLAP, analytical processing workloads. And the core part of the technology that I didn't go too much into is I believe they have a patent around something called micro-partitioning. And so these micro-partitions are 50 to 500 megabytes, and they're not the same as a B-tree index, but they basically have metadata associated with them. And Snowflake uses this pruning technology to optimize how it quickly gets the data returned from it. And so that makes it more performant than like your standard RDBMS systems.
And you'd mentioned this is where you shifted your consulting company's focus. Could you go in broad strokes? Who were the early adopters? Were there particular industries or technology-forward companies? What was the common factor in people who said, we want to migrate to this?
It's a combination of things. I think there's been a lot of movement. IBM sort of like ended Netiza's life. And so there's a lot of movement from that. There's a lot of movement from Teradata. There's still quite a bit moving from Oracle. But then it also took a lot of the Hadoop workloads too. I think people were frustrated with the complexity and challenges associated with that. I think it's taken it from quite a bunch of all those different areas. And then the other thing, like Snowflake, besides just being a regular RDBMS, it does handle JSON data really well. What it does is when it ingests that JSON data, it sort of builds like a mirroring. As it's ingesting it, it looks at all the JSON and auto-analyzes it and builds like a mirror of the relational parts of it so that you get into the same optimizations around the queries with that as you would a regular relational data. So both, they call it semi-structured data, so both XML and JSON. So it handles those workloads a lot better. They've really, though, expanded it now, too. Like I said, I never would think of it for OLTP, but I think there's talk, there may be some movement in that direction. But because it's using these micro partitions in the back end, these are really like these basically immutable files. And so when you do an update or a delete, it's actually writing the files ahead. And this is how they avoid the contention you have on most systems, because if you think about it, you have these immutable files and you keep just writing them forward. You can basically, this allows a lot of their new tools like time travel and cloning to be done as well. And you just use that one copy of the data. The most live data are the one with the query ID at that point of the transaction where you can get back to it. So it's really like still for analytical workloads, but it handles not only like I said, structured but semi-structured, and now they've added unstructured as well. So there is some people doing more, I think, related to yours, data science, where they're actually using it, like bringing in files or videos or pictures, and they're processing those in data science workloads as well. And finally, they have something called Snowpipe, which basically is you tie, like for S3, you would tie like an event to the bucket, and it's telling Snowpipe, hey, there's new files coming in, process these. So it processes them in batch. So you can, I know for, I think like the Oscars, some of the other things, they do this near real-time feeds and can handle basically like Kafka also has a connector to it where it can get near real-time, or whatever you want to call it, like continuous pipeline data to it.
Well, let's get into Snowflake Essentials, Getting Started with Big Data in the Cloud. That's the book. Who's this really for? Who's going to pick it up and take advantage of it?
I think the primary reader of this is going to be anyone who's working with data and a data professional that's looking at either moving to Snowflake, or their company or has already moved there. I mean, one thing about Snowflake that is really awesome that I didn't mention in the beginning is, when we deployed Oracle, Teradata, Netezza, big data, or RDMS solutions, typically your customer was going to spend hundreds of thousands of dollars. The great thing about Snowflake is you can start a trial for free for 30 days. You can be a very small startup, spend $10 a month if you have tiny data workloads, or you can be massive customer and be spending millions of dollars per month or whatever. So one of the main reasons why people moved to it was there was a lot less risk in cost structure. It wasn't like you had to have this big bang, like I'm going to install Netezza, Teradata, or Oracle. I have to get all the infrastructure ready, and I have to, plan the story is like you build it for Easter Sunday, the church, so it can handle that high workload, but most of the time it's half that capacity being used. So going back to, I think the readers are, anyone who's a data professional and looking at cloud databases and wants to move to Snowflake. It has a getting started chapter, so it's really for people kind of new to this, and it really gives the essentials or the basics of Snowflake.
Well, let's talk about that getting started path. What's the typical on-ramp? Is this a tool that an ambitious young engineer who wants to try some things out brings into a company, or is this like executive level down making a decision?
It can actually be both. Like I said, the great part about Snowflake, and one of the things I just really loved about it was, you really couldn't bring big data solutions to any startups or smaller companies without serious money allocation. And so, you can be an engineer and get started from it, get some type of security approvals and show off what it can do. Most of the time, people in corporations, they've been doing this for years, is proof of concept. So they'll bring over a couple different workloads and then they'll test it out on Snowflake. And most of the time it crushes the competition. And then they gradually move over to it. That being said, there's plenty of places where, the executive came from another place where they were using Snowflake or knows about the performance of it. So the executive actually brings it in as well. And most enterprises deal with setting it up with Okta or some type of third-party identity management tools. So while it's super easy to get started with a regular username password, typically when they want to scale it for an enterprise, it's going through some type of combination of security approvals. Snowflake is encrypted end-to-end at rest and when it's moving, but most larger enterprises, they need to go through those testing and share some of the security tests, penetration tests as well.
So you raise a really good point about this kind of lowering the bar, that, a typical startup was not about to sign a 3-year contract with a big company, making it accessible. What kind of workloads does that unlock? What are smaller companies now able to do?
Well, the biggest thing is if you have some massive data science workload, especially that before you'd have to run X amount of EMR instances or EC2 instances or a larger RDS like a data system, you can just bring it up for like 5 minutes on a 6XL on AWS. I think only 5XL and 6XL are on AWS, but it's up to 4XL on the others. And so that's like 512 EC2 instances cranking up for 5 minutes and running this massive workload. And, it's kind of like crazy, but you can do things like that you could never do before. Like you'd have to spend $1 million to even get a tenth of that kind of CPU horsepower behind it.
So if I've got that much data, it's going to maybe be a challenge for me to get it ingested. Do I connect Snowflake to wherever I've got that data now and it's able to import it, or how does that process work?
So it does depend on the size of things. Ironically enough, I can't remember the thing off the top of my head, but AWS has like another tool like Snow. It's basically a big disk that comes to you and you unload it. So when you're talking about many amounts of terabytes, it's going to depend upon your network bandwidth. But you can load, terabytes per hour into Snowflake. It can handle it pretty well. But like I said, if you're like a bigger place and you have this on-prem, or you had a data center, then you use, it's called Snowball from AWS. And I'm assuming Google or Microsoft has something similar. It's basically they ship you out a disk and, from this data center, you unload it and move parts of it over. But if you have real bandwidth, you can just move it over that as well.
Thanks to today's sponsor, Nomad Data. If you've been listening since 2016 or went back through the archives, you might have encountered our Potholes episode. It was my experience interacting with the Los Angeles City Data Portal. It was a bit of an adventure, really, and had to get help from someone from the city. Shout out to Chelsea if you're still listening. And I've always been a supporter of these data portals. I think they're important, but navigating them can be a little rough. More recently, there's been this advent of data marketplaces. You've got Amazon, Azure, and Snowflake doing their own thing. Big players with no parity across them. It's not the data ocean we were promised, it's the data temple of doom, and I don't have time to be Indiana Jones. That's why I was excited to learn about Nomad Data. They're more like a matchmaking service. They're connected with some of the biggest data resellers in the world. Their technology takes your request and matches you to the ideal potential data providers. Here's one of the examples over at nomad-data.com. I'm looking at investing in European telecom markets, and I need detailed information about what broadband service each carrier offers, and actually gets a bit more specific from there. I don't know where I would begin to gather a data set like that, except to go to Nomad Data and put in my own request. If you need to make business decisions now, you don't have time for a research project about data. Connect with the right provider and start moving today. That's what Nomad Data can help you do. So head over to nomad-data.com and tell them what you're looking for. If you're looking to progress into a well-paid, fulfilling career in data science and machine learning this year, Springboard's 6-month data science bootcamp is built on human support and backed by their job guarantee. It's 100% online and on your schedule, with over 500 hours of structured data science and machine learning content, and most of your time is dedicated to hands-on work for a portfolio that will stand out to hiring managers. You're paired with an experienced industry mentor that will meet with you one-on-one every week for technical and career guidance. You'll also have your own career coach guiding you through the job search with behavioral and technical mock interviews, networking training, and more. Springboard's data science graduates average an increase in salary of almost $24,000 a year, and they've been hired by the likes of Facebook, Apple, and Google. Their job guarantee also means that if you don't land a job within 6 months of graduating, they'll fully refund your tuition. Visit springboard.com and use the promo code DATASKEPTIC, all one word, to receive a $750 discount. That's springboard.com, promo code DATASKEPTIC. Well, we've talked about it being a database with a SQL interface, but you alluded to some of the more advanced features, regression being one of them. That's not something I'm typically expecting out of my query language or my database. What sort of extended features are there that might surprise a listener?
I think it's just like more for your listeners. There's a whole ton of functions I mean, there's like the standard stuff with all the aggregations, but I think some of the ones that, like lead, lag, rank, dense rank, there's a whole set of regular expressions that they have, pretty extensive with that. There's several regression functions they have there, like regression, which, returns the average of independent variable for non-null pairs in a group. There's about 10 different functions with regression type calculations. One of the cool things they have too is that you use a lot in practice is it's kind of like, hey, give me the last data set that you got. So result scan functionality. So you can use within procedures some automation to basically like query something, get the result set, and you're still in the database. You really haven't moved it back anywhere, and then process that database within a procedure in a loop to do things that you wouldn't think you could always do within a database. The other big functionality that not a lot of people realize, and we helped pioneer it, is this concept of basically user-defined functions that run across data shares. And so you can use these to build like data clean rooms. So each of these functions will pass in data. And so you get around the issues associated with GDPR, CCPA by basically sending data that's encrypted and anonymized through these systems. And you can get, for example, like with advertisers, you can see which customers you intersect and then get data about them back, but you're not passing any personal data at all. So that's one of the really cool functions as well, is this secure user-defined functions that run across their data shares.
If I wanted to build one of those up, what's the development process like?
So we have some articles on it. It's not as bad as you would think. It's several procedures. Snowflake, I think actually some of the guys I worked with on this patented parts of it, but it's really, you typically work together with some type of partner. You build typically a combination of data sets and these secure user-defined functions. Secure views too, where the secure views on the Snowflake side obfuscate what's the actual select statement creating the views. So you don't know what's going on behind the scenes. So no one can try to guess the customer's email or things like that because the secure view obfuscates how the data is coming. But yeah, it's just a matter of create a data share. You work with another partner, share that data share, and then you create user-defined functions on both sides that share this information encrypted. And typically you have tasks. Snowflake has a concept of, it's kind of like a cron job in a way, except it has hierarchical mechanisms. So like you kick off a task and it can launch another task and it can launch another task. So can be hierarchies of them. But typically that's what you would do is set those up. They run regular procedures or functions that would run to share this data across systems.
Now, I see a lot of value in the analytics workloads you're describing. One example might be a big company that does like VPNs and firewalls, and they've got to do billing, and that billing is somehow based on usage. There's just these massive logs they've got to aggregate. If those can go in, awesome solution. It's a SQL statement at the end of the day. When you start to get into more data science tasks, it often feels like, my needs are unique, and it's not always the case. But I'm just curious if you've seen any use cases or example rollouts of people doing, I don't know, either if it's machine learning prep work or if there's anything interesting they do with the user functions that's kind of going above and beyond what we might put in our traditional RDMS.
Well, Snowflake has come out last year in 2021. I think they initially did it in June at their summit, like a beta. Now it's, in general public. They have something called Snowpark. So originally in June, it came out with Java functions that you could run separately from Snowflake and is designed to handle data science workloads. And then Python became available, I think, November now. When I first sold these things, 2018, 2019, I was actually at the Snowflake Databricks, like when they were partners and friendly to each other. I was actually at that event. And then I think they decided to go different ways. And, so I still mostly did solutions where I did a lot of the ML, AI type workload on Databricks. And then, we would you can basically connect Databricks or Spark to Snowflake, and you can actually, I've done this with different customers where you can, move data frames or push that data into Snowflake, or you can pull it out of Snowflake and put it into data frames for analysis. So that's how we used to do it all the time. And I still think that works. It's more mature. And then, like I said, now Snowflake has opened it up to where they actually just had a new partnership with Anaconda. So they're trying to basically take on some of those data science workloads as well natively within Snowflake and not just with Spark, or there's a lot of the other, Data Robot, Dataiku. They work with a lot of those other vendors as well to do machine learning type workloads.
And what's the typical workbench like then? Do I do everything via the Snowflake web console, or is there a Jupyter Notebook option? How do the typical users interact?
Typical users, there's really like a few ways to access the system and process it. So I'd say the regular data professional at least starts off with the web interface. In the book, chapter 4 covers the classic console, which is actually pretty good. And that's what they've had since the beginning of time. And now they bought this other company called Numeracy a couple years ago. They put a nicer interface to it, and they call it Snowsight. And this interface, it is pretty cool because they're taking Snowflake from just your standard, okay, write my queries, get my result sets, or even do the programming, to where there's a few major really cool things around Snowsight is they allow you to share worksheets. The worksheets actually have versioning on them, and then they allow you to share dashboards. So all of a sudden, mostly you had to do it through Git or some other mechanisms. Now you can actually share these through the Snowflake interface on the web side of things. So Snowsight's really the web interface. And then they have something called SnowSQL, which is the Snowflake command line interface. And just like anything else, you can use it with Bash or shell scripts. And similarly, you just log in and then you can run commands. It opens up a lot of different avenues for programmatic access to it. And then Visual Studio Code, there's actually a connector for Snowflake in there that you can run. And if you're more in that development environment, that's a lot easier than going back and forth between the web interface or the CLI to do that. And then finally, there's tools like dbeaver. Anything really with a JDBC connection you can use to connect to it. But I think the one I've seen the most, or I've used personally, is dbeaver, like a third-party tool that gives you more of a GUI interaction interface.
Well, I've heard a lot of familiar things. I don't actually myself have a whole lot of hands-on experience with Snowflake, but I've seen its growing popularity. And if I were out looking for a job, maybe I'd want that bullet on my resume. How difficult is it, or maybe how much time would I need to plan to invest in some ongoing education picking up the system if I'm already a data professional familiar with other data warehousing solutions?
I would say if you're a data professional, you know SQL very well, like windowing functions, it's really easy, honestly, to move over to Snowflake. You have to understand some of the core different concepts like file formats and stages, but you can actually be removed from this is really the warehouses. Like, I think it was a poor naming choice, but warehouses are really Snowflake compute. They're really like just pointers to compute. And besides those, like I said, file format, stages, warehouses, all the select statements, all that stuff is very similar. Like if the last 20 years or more that I've done this, from Oracle to MySQL to Postgres to Netezza, Teradata, it's all really the same type of things with the same CRUD type creating tables. And I think one of the things that Snowflake did really well and why it gets really good adoption is because they made it all standard ANSI SQL, and even these new objects, like I said, file format, warehouses, which are just compute pointers, they still use the same exact syntax, so it's similar. Like you create a warehouse, you create a file format, you create a stage, you drop these same type of objects, and there's show commands for pretty much every object. There's describe commands for tables. It's very, very similar. If you come from a SQL RDBMS background, it's pretty simple transition. And the book really is made for those data professionals, like they're moving over. We do have getting started and basic aspects of it, but we cover all these things so we make it easier for you to transition into Snowflake in the Snowflake Essentials book.
So I've got a sense of what Snowflake is as a data warehousing engine. I get the feeling though there's like satellite stuff and the roadmap of the future to come. What does the Snowflake ecosystem look like beyond the data warehousing, and where is it going in the next couple of years?
There's an evolution, I think we talk about in the book, but it's also on their site where, like you mentioned, the guys who built it at first and the original founders, I think they really in 2012, 2014, 2016, they actually have a really good paper that they presented. It's called a Sigmoid paper on their vision of what it was. And at that time, it really was a data warehouse. And then they kind of mentioned that it transitioned for a couple years to a data platform. And now they really position it as the data cloud. And I think the biggest thing why it's a data cloud is really this zero copy immutable micro partitions on how it works. And those enable it to do this data sharing, which, for you and I have done this for so many years. I don't know how many SFTP jobs or API calls I made over the years or to work with customers. They remove all that. And like I said, this data marketplace that they have, especially in the financial services, there's already, I think, like 250 data providers there. And so if you were this asset manager or insurance company, and before you had to run these SFTP jobs or some type of data movement jobs, now you can just go to these data shares. And I think that's really their key core concept around the data cloud. On my site, snowflakesolutions.net, we actually track this data marketplace growth. And I think that's really differentiating it. And Snowflake Snowpark, which does have I didn't mention it before, that does have a Jupyter interface associated with it. And so that's their other big play, is they're trying to take on data science workloads as well. I think that's probably one of the biggest areas they've positioned themselves for beyond the data cloud workloads that I've mentioned.
Well, let's wind up by doing a little deep dive on this marketplace data sharing stuff. So if I understand it correctly, I could be someone who amasses some important set of measurements. Maybe it's weather related or something like that. And there could be other people, maybe you're my client, you want to get that data from me. And I can use that sharing function to facilitate that, correct?
Yeah, honestly, I've been writing about it since 2018. Probably one of the top thought leaders associated with zero copy data sharing. I think I'm the only one actually tracking the data marketplace independently from Snowflake. It's pretty phenomenal. You can have your data set as a data provider, and because, like I said, these immutable partitions, it's just, if you think about those, you can have near real-time data, even if you're in the trading floor and financial services, and you can give that near real-time data access to any partner who's paying you for it, or, there's a bunch of publicly available ones. So the marketplace conceptually is pretty phenomenal. And one of the things that Snowflake is doing to, I think, make themselves even more of a platform company is I actually run my own data share as well. I have the local area unemployment data from the Bureau of Labor and Statistics that we post every month. And there's a whole new data provider interface so I can see the different people who are using my data. So they've made it easier and easier for these data providers to provide this access to customers without copying. So I think that's one of the key concepts to understand. Anything we did before, even if you could move data at massive network speeds, there still was some latency associated with the copying. This prevents that within a AWS or Azure or GCP region. If you do have it between regions, there is copying, and they have a whole replication service for that. But if you're in it, that's just amazing, because you can have security data, as you mentioned. There's probably 100 security vendors of data where you can share, phishing or other sites that are doing something, or they have financial services data, they have marketing data, there's environment data. There's about 18 different categories of data that Snowflake has on the data marketplace so far.
And with regard to tracking it, can you throw some stats at me? How do you measure the marketplace, and how do you know it's growing?
So I actually helped Snowflake in the early days, where I was one of the beta testers, and they used to, before it became the marketplace, I think it was June 2020. It was the data exchange. So basically, we look at it each month. We're moving to weekly, and we just look at the number of shares that are there, what they're providing. Also, we track like which shares are. Some shares are actually open, so all you need is a Snowflake account, and you have to be on that same region. We only track AWS West, Oregon. So that's where Snowflake was originally built, and that's where, I guess, I've set up a lot of my accounts. So that one is the one we track. But technically, like I said, there's, I don't know now, like 8 GCP, 12 Azure, 16. I don't have the exact number. It's in the book, which regions they cover. So each of these can have different marketplaces on them, but we just been assuming that AWS West has all the most popular ones, so we just track that. And so the growth we've seen, we report on snowflakesolutions.net, is there's usually 20 to 40 new data shares per month. So right now we've been tracking it. We check it at the beginning of each month and see, what's new, what's grown. But I said by far, I think it's marketing and financial services are the two biggest categories.
And can you give me a sense of what people get out of that? I mean, you mentioned your unemployment statistics. Are there a few other canonical ones you see being popular?
Yeah, I mean, there's some big data sharing vendors on there. Like the one that comes to mind, or one of the biggest ones, and I think they have about 40 different data sets on there, is FactSet. They're really well known in the financial services space. So they provide everything from like mortgage data to, there's a lot of ESG data on the system. The two most popular ones that I understand are out there is actually weather. And that has, they call it stable edges, where many people are looking at this data sets and using it on a regular basis. And then there's this company called Star Schema that put out this COVID-19 data set and has been maintaining it for almost 2 years now. And that's the other one that's very popular and used by many corporations to basically forecast business, or sometimes it's healthcare companies of what's happening associated with COVID.
So when you have the data like that, let's say go with the weather, since it's an easy one to think of conceptually. Somewhere in my database, I've got a table and it's got, an address. Let's just assume I've got it broken down real nice, where I've got state in a column, lat long, zip, whatever you need. Do I do something that appears like a cross database join, or how do I get the data?
So that's actually a great question. And we're actually working on some ideas conceptually around that. Is, some of the challenges you have is your internal data set may have different join keys or structures than that weather data set, like you mentioned. And also, I did want to mention, like, the other piece that Snowflake is doing and just released for us data providers is, before you had to independently negotiate, like for a FactSet, it was mostly for customers they already had on the system. Like before this, they had APIs that did all this. And from what I understand, it was just much better to move it to Snowflake and easier to maintain. But now Snowflake has gotten into the middle of the transaction, kind of like, an app store, where you can actually buy the data online and it's going through Snowflake, and they take a commission from the data providers. So they're trying to become part of that platform in the middle of that now. But what you alluded to is still a challenge. Like if it's a data set you've already used, it's like a no-brainer, right? You're using FactSet here, are you using weather source data here, and you already knew the DDL and the constructs of it. It's a simple move. Now, if it's completely new, there's a whole process that some companies are working on to automate, is like data discovery, right? Is this weather data, or does this financial data really meet what we need? Do we have internal keys that are correctly, like you said, like the right lat longs for the city that join to get the correct data? So there still is a whole process around, data sharing and making it public is awesome. But at the same time, there still is that data engineer, or at least business analyst, data professional, that has to match that data and also make sure they have the appropriate grain and they're not summing something that cannot be summed. Things like that there's still, we got rid of the whole ETL, ELT part of that aspect of it, but there still is an understanding of the data. And also the next gen, which Snowflake is doing a lot of work in too, is the data quality too, making sure that data on the data share is timely, is the correct quality, not like all the stuff we had to deal with the last 20 years where, you're moving data from one partner to another and all of a sudden the file is empty, right? Or someone moved a column in the wrong place. So you still got to make sure that the sparsity of the data is what you expect and it's not missing keys, things like that. That is one big concern as you move to more automation, is making sure you're pre-checking the quality of the data before you process it for any ML jobs or things like that.
Yeah, absolutely. That's a whole episode in and of itself right there, at least.
Oh, for sure.
Well, Frank, remind listeners where they can find the book.
Well, the publisher is A-Press, Spring Nature. I think most people buy it on Amazon. Just search for Amazon Snowflake Essentials. And I just want to thank, too, Kyle for having me on your show, on the podcast. But I also wanted to thank, I was the primary author on this, but I did have help from some other colleagues, some of the people I work with part-time at Accenture, Raj, Bhaskar, Bjorn, Ruchi, and Samir. Thanks again, all of you who helped me get this book through the system. It ended up being a lot more work than I expected, but yeah, you can find us Amazon Snowflake Essentials. Grab yourself a copy, especially if you're new to Snowflake or want to learn more about it and get all the basics, the essentials on Snowflake.
Very cool. Well, thanks again for coming on Data Skeptic.
My pleasure. Thanks, Kyle.
That concludes another episode of Data Skeptic. Our guest today, Frank Bell. Thanks to our sponsors, Nomad Data and Springboard. Myself, Claudia Armbruster as associate producer, Vanessa Bly, guest coordinator, and our host, Kyle Polich.